So yes, you read the title right. Today we are going to talk about math, specifically permutations. Let's start. We all know that a Rubik's Cube has 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 489 million, 856,000 possible permutations. But that is only when you do pure turns. If you count permutations through disassembly, then you'll find that there are 519 quintillion, 24 quadrillion, 39 trillion, 293 billion, 878 million, 272,000 total permutations. If that doesn't seem big, let's put that in perspective. If each permutation equals to one Rubik's Cube, then someone could cover the entire Earth 3,300 times just with Rubik's Cubes. But it doesn't stop here. It gets even bigger. We haven't talked about taking the centerpieces apart yet. So let's see. If we count the number of permutations when we take the centerpieces out, the number of permutation increases to 373 sextillion, 697 quintillion, 308 quadrillion, 291 trillion, 592 billion, 355 million, 840,000. And now, let's take a look at how it works. First things first, let's disassemble the cube. Now, when we talk about edges, it fits between two centerpieces. And there are 12 edge pieces or 12 places to put the edge piece. So if we take our first edge, we have 12 places we can put it in. So let's put it anywhere, let's just put it there. Now, we have a second edge piece, and this only has 11 possible places because the other edge piece has occupied a space. Then the third edge piece has 10 places, then the fourth has 9 places, and so on. So for those who know permutations, they know how to calculate how many permutations are there, but if you don't, you just multiply the numbers, so that's 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That, you just multiply them, or you can write it as 12 factorial, which is just 12 with an exclamation point. Now let's take a look at corner pieces. A corner piece is at the corner, and there are 8 corner pieces. So, like with the edges, we have 8 places to put it in. Let's take our first corner piece and let's just put it there. Now for our second corner piece, we have 7 places to go, and so on. So now we have 8 factorial, like with the edges. But we forgot something. Let's rewind back. So we can put the edge piece with green on top or orange on top. So what I mean is that each edge piece has 2 different orientations. So since there are 2 orientations and there are 12 edges, there are 2 to the power 12 possible orientation for edges. Now for the corners, we have the same thing. We can put blue on the top or orange on white. So there are a total of 3 possible combinations. Now since there are 8 corners, the total combinations for orientation for the corners is 3 to the power 8, just like with the edges. Now, if we multiply the numbers we gathered, that is 12 factorial multiplied by 8 factorial multiplied by 2 to the power 12 multiplied by 3 to the power 8, it is equal to 519 quintillion, 24 quadrillion, 39 trillion, 293 billion, 878 million, 272,000 permutation. Okay, but let's try to solve it. So, let me just skip to the last layer. So we have an edge piece flipped, a corner twisted, and after doing all that, an impossible PLM. So, to fix this and make it solvable with only turns, we have to fix something in our formula. For the flipped edge piece, we should go back to the last edge piece we put in the cube. Now this edge piece, we said that there are 2 orientations. But this one could only have 1 orientation, so that the cube is solvable, otherwise the cube is not. So in our formula, we change 2 to the power 12 to 2 to the power 11, because the last one only has 1 possible orientation and not 2. Now same thing with our corner. There's only 1 possible way we can orient the last corner so that the cube is solvable. So the 3 to the power 8 becomes 3 to the power 7. Now the last thing we need to change is the corner permutations. We wrote 8 factorial, or 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But the last two corners only have one specific place so that the cube is solvable. Otherwise there will be two corners switched or two pieces switched, and the cube will not be solvable and there will be an impossible PLO. So now this changes to 8 factorial divided by 2 multiplied by 1, or 8 factorial divided by 2 in simple terms. Okay, let's see what all of this equals to. It equals to 43 quintillion, 252 quadrillion, 3 trillion, 274 billion, 49,856,000 permutations. And that's the number we got earlier. Great. Now let's go back to our formula, our first formula. If we could take the centerpieces apart, we have 6 centers, and the first center has 6 places it can go in, and the second one has 5, the third one has 4, and I think you guys get the hang of it. We're gonna get 6 factorial. So if we multiply this formula by 6 factorial, we get 373 sextillion, 697 quintillion, 308 quadrillion, 291 trillion, 592 billion, 355,840,000 permutations. And these are the numbers we got earlier. And that pretty much wraps up this video. If you guys like this video, don't forget to hit the like button, and if there are any questions related to cubing, let me know in the comment section below. And until the next video, happy cubing.